Dr. Wei Zhang?
Okay.
Go get them.
Okay. So the topic I'm going to present is visualizing the benefit of restricted crossing U-turn intersection design at a high-speed two-way stop control intersections. Okay. And this is the outline that I'm going to go through, and we'll talk about the problem we want to address. And one of the viable solutions for that particular problem, and we'll talk about the safety facts of completed RCUT intersections. And then we'll talk about how we visualize the different design aspects of the RCUT design, and how do we balance mobility, safety, and cost at both program level and at a project level. Then we'll come to some conclusions. So one problem, with if on an arterial road, okay, once the traffic demand increase to a certain level, and this is what you are going to see. As doesn't seem to be a lot of traffic, but the speed is high. The vehicle would not have the gap to enter the intersection. So what you see, even if there's only one vehicle, that vehicle will wait there for a long time. This is not even during the peak hour. This is already after the morning peak hour. Okay. And certainly another problem that's more pressing we want to address is this kind of a safety problem. This is a real intersection, real footage of crash. This intersection was protected by a technology called stop sign control. It's ITS technology that provides gap information to drivers, but the technology can only do so much. When the volume increases to this kind of level, you see this kind of crash. It's very dangerous. This is on the local news. This is one of the locations. This is in Minnesota. The state DOT is saying that what we are going to talk about is going to address problem. So the solution for that kind of crash problem is what we call it restrict crossing U-turn intersection. And the concept is actually basically we put some barrier block the main intersection to prevent minor road driver from making a direct through or direct left turn move. Okay, channel all the traffic to turn right at the intersection, then provide a U-turn opening some distance, and for those people to come back to complete their design the movement. Okay, and that's not a problem for motorized vehicle or even for large trucks, but for bicycles, that's going to be a problem. So in this design also provides some kind of opening at the intersection to allow this kind of non-motorized traffic, to resolve conflict from this side and enter a protected area, wait for its gap, and complete its move. Okay. And this is a real intersection in Maryland. This is what you see. They use this as a corridor treatment, and the main intersection will look something like this. So the minor traffic will not be able to go through the intersection. So they enter it, do a right turn, and then come back through a U-turn, something like this. And this is a corridor treatment. Okay. And there are two forms of RCUT design. One is called the rural RCUT. This is for rural areas, and Maryland use this a lot. They also call it J-turn. And it's basically, the concept is we basically alter the minor road traffic movement, alter their travel route. And by doing that, we eliminate the far side angle conflict. That will eliminate those kind of angle crash, okay? And allow drivers to deal, because we put this U-turn opening at a certain distance, because that allows drivers to make a right turn and accelerate, change lane, decelerate. So there's many tasks the driver has to do. By providing this distance needs to be sufficient to allow the driver to do all those movements, okay? And then there's the issue that you can decide whether you want to provide an acceleration lane at the right turn or not. There's different design philosophies. In Maryland, they turn to provide a right turn acceleration lane, and that can go all the way from here. It's almost like a freeway on-ramp. And in North Carolina, Minnesota, they turn not to provide acceleration lane, and some locations they design the geometry in a way that this point will channel the driver directly into almost a left turn pocket. And how you do your design, that depends on the traffic volume and traffic speed. So you have to do it on a side-by-side basis. And another version of the RCUT design, say if your traffic volume increased too much, and even if you do this, they still not even have the sufficient gap to even do the right turn. In that case, what we do is assuming the speed will be lower on the major road, okay? So say rather than 65 mile per hour speed, maybe the speed in that case would be reduced to 45 mile per hour or 50 mile per hour. In that case, you can put a traffic signal here to stop the major road traffic, and that signal will provide a gap for the minor road traffic to do the right turn. So this is the signalized version of RCUT, and it is also called super strict. It's a very inefficient. It's basically it turns this complicated intersection into a few T intersection that allow you to operate in two-phase mode. Very inefficient. Again, you can also use this for corridor treatment, and pedestrians again will use this route to go through the intersection. Okay, and some fact about is this design safe? Okay, this is just give you an example. These are the different RCUT that Maryland has implemented, and these are the result of all those intersections. Okay, you see during the before period, and these are the fatal injury crash that occurred at those different RCUT intersections, and after they implement the design, this is after period. You can see there's in most sites you see dramatic reduction in fatal injury crash. Okay, but I use this as an example because all these intersections incorporate a wide variety of different traffic conditions. Not every intersection see improvement. There's one particular intersection right here. This intersection actually see increase in fatal injury crash. And that increase is due to, we think, insufficient distance of the U-turn offsite. And because these two intersections, they are next to each other, okay? And they are ADT level similar. But this one see a 4% reduction in crash. This one see a 40% increase. And if you see the difference here, these are all T intersections. This U-turn opening is 3,000 feet. And this U-turn opening location is only 1,900 feet. So this intersection itself, it did not provide enough distance for acceleration, changing lane, and deceleration. That's probably what caused the increase in the crash. And another thing maybe you can see is once the traffic volume increased to say 40,000 ADT, even if you provide 3,000 feet U-turn offsite, you still don't see the 4% reduction. That's very marginal. You don't really see the benefit. So that's probably the limit that you will use this design. Anything higher than that, you really should think of great separation. Okay. Another thing, I just want to point out again, these two intersections, they have similar, identical ADT value, same speed, and one sees 20% reduction, the other sees 80% reduction. And again, if you examine their U-turn opening distance, this one is 2,000 feet on one side, 2,500 feet on the other side. And the one here is 3,000 feet in both directions. So that's extra 500 feet provide all this, the different improvement in safety, okay? And the TV program that I showed you, that's actually an actual public meeting. There was a lot of people, over 100 people came to that public meeting, and most of them voiced opposition to this design, okay? And that's not unique. Anytime you try something new, this is the kind of a situation that you have to plan with. There will be a lot of people come out, and they don't want this kind of design. They want a great separation. They want traditional interchange, okay? And so we have to come up with a way to convince the public. I mean, this is something that's going to solve your problem under the given traffic condition, okay? And based on all those crash data, we came up with some kind of regression. We did some very quick regression, and these are the results we came up with. For example, if your minor road ADT is 1,000 vehicles per day, your major road is 10,000 vehicles per day, and that's the kind of based on the, depending on how far away you put the U-turn opening, and that's the expected annual number of fatal injury crashes you can expect. And if your traffic volume increase, and you use a different curve. So we come up with this kind of curve to basically tell the locals that, you have this kind of traffic volume, you have to set a minimum distance to a certain distance, okay? Otherwise, you're going to have a crash issue, okay? Because, some people say, why do I have to travel an extra, a mile to come to this location? Is it worth it? And this shows it is worth it, okay? And this is another situation if your traffic volume is not very high and you try to improve the intersection with traffic signal, and this is what you end up with. This is used to be a two-way stop control intersection, and after the state put in traffic signals, they did not see any reduction in the total crash, okay? They actually see a dramatic increase in the total number of crash. And the angle crash, the far side angle crash, also pretty much the same. And then in 2007, they converted this into an RCUT intersection. And what you can see is after converting into an RCUT, the total number of crash reduced, the angle crash was eliminated. So this is what you will see in terms of the safety benefit between traffic signal and RCUT design, okay? And now we need to come up with some way to visualize this, the different aspect of the RCUT design so that we can go to the parkway meeting, have the citizens, examine this design in more detail, okay? The first thing we want to illustrate the number of conflict points. With the traditional two-way stop control, you have, at least 46 conflict points. Just by doing RCUT, blocking minor road traffic from making a direct through and left turn, we reduce that to 24 conflict points. So that's a 50% reduction in the number of conflict points. It eliminated a lot of crash, okay? And then we come out with some kind of simulation, and Jason is there. Jason is the person who helped us implement all this traffic simulation analysis into the more realistic driver simulation videos, okay? And this basically shows the, okay, well, okay, this shows if you have two-way stop control condition and traffic has to go across intersection, and the one down here shows if you have RCUT, now they don't need to go through the intersection. The gap they need now will be much less than this to go through the intersection. Okay, so this is from bird eye view, the difference of the minor road traffic. This is what we call intersection control delay that they need to experience. And this is the driver view, because a lot of people said, I wanted the U-turn opening only 1,500 feet from the main intersection, okay? And this basically shows with the traffic, if the volume is high, you can't really do that. And this is what you see here. This is the speed of the vehicle. And this mirror you will see shows the traffic from behind. And the top mirror here also shows after you make a right turn, you need to accelerate. There's a lot of things the driver has to do. You need to provide enough distance between this right turn and that U-turn openings to allow drivers to deal with one conflict at a time. Okay, if you don't provide sufficient distance, that driver may end up into a side swipe crash and safety problem. Okay, and these are different settings that you will see. You can, whatever setting you do, you can actually see it from here. And if you, okay, so this is the driver view. And this is, we try to illustrate, there's if a passenger car, that's how you're going to drive through the intersection. If you have a large vehicle, in this case, the particular location we started, they have a lot of farmer equipment. Big, slow, and they don't think this design is going to work. Okay, we don't have that farm vehicles in the library, but we do have the tractor trailer. This basically shows, large vehicles, how that kind of vehicle navigate through the intersection. Okay, you do a right turn and allow enough distance to accelerate, change lane. This is a driver simulator video. We do the simulation in VSim, and we output the simulation result, and Jason input those results into his driving simulator to generate this kind of realistic videos. Okay. Yeah. And that's how a large vehicle will do the U-turn, rather than passenger car will U-turn into this lane, but large vehicle you have to turn into this lane. There's a loom, it's called. And again, there's these are realistic traffic data. This is basically showing how a large vehicle will do this kind of move, okay? And then we have another kind of user, non-motorized traffic, and pedestrians and bicyclists. How will this type of users go through the intersection? And, okay. Now, because in this case, the traffic, the traffic on the minor road is very low. It's during the peak period. The highest period is 100 vehicles per hour from the minor road. So it's very easy to resolve the traffic conflict on the minor road. So basically, we'll provide something for the bicycle or the pedestrian to come here. And then in the protected area, and then wait for its gap, go through, and okay. So basically, this video shows how non-motorized vehicle goes through the intersection. And then about 2 weeks ago, I went to Maryland to look at some of their RCUT sites, and they do have this kind of design actually already implemented in the field. Okay. And so that's a different design aspect of the RCUT intersection, how you navigate different type of users, navigate through the intersection. Now we need to talk about how do we balance mobility, safety, and cost, okay, by selecting the right tool, okay. And this is one example in Minnesota, two-way stop control intersection, and this is kind of crash history they have. More than 50% of all the different type of crash was a right far side angle crash, okay? And they don't have a lot of crash, but every year, for many years, every year they have certain number of fatal injury crash, okay? And this is the data ADT at that location. The major road, there's about 30,000 vehicles per hour. That's 95% of the total volume. And the minor road traffic, daily traffic is 1,400. That's only about 4.5% of the total ADT at the intersection, okay? We have three options. The locals want to have great separation, okay, interchange. Interchange definitely will resolve the far side angle conflict, okay? Will give you the mobility and the safety, okay? But that option costs a lot more. And traffic signal, cost-wise, is similar to RCUT design. But with the traffic signal, what you're seeing is actually you're stopped the major road traffic and then serve 5% of the minor road traffic. So it's actually, you have a lot of degradation to the level of service on the major road, okay? And if the volume is not there, it doesn't mean the signal warranty, and the experience tells us this traffic signal does not give you the safety. It actually you probably can expect more crash. And with RCUT design and the experience in Maryland, in North Carolina, in Minnesota, we do see, this design, if traffic volume is not that high, it's very forgiving. You can see a dramatic reduction in the number of fatal injury crash, okay? And these are the traffic volume that we studied And just to give you some sense, with the existing condition, the minor road, even though peak hour only has 100 vehicles per hour, it's already reached its capacity, okay, in the existing condition. Okay, if the traffic demand increase in the future, it's going to be even worse. Just by turning that into an R-car design, this allows vehicle to go through and make a direct left, and that immediately brings down the V over C ratio to less than 50%. Okay, so we preserve the level of service on the major road, and by the way, increase the capacity for the minor road. So basically, drivers from minor road will have more gap to enter the intersection. Okay, and now another distance we need to convince the locals. You need to set this U-turn opening at a sufficient distance, and this is how we illustrate. We break down the total travel time from here to here, or direct move. We break down into the this is called intersection control delay, which is this, and then we introduce some geometric delays. Okay, the actual distance the driver has to travel, and there are some control delay here, and then some additional geometric delay. These are the different components. If you have two-way stop control, and most of the time you're basically waiting at the intersection, so you have a lot of intersection control delay. By turning that into an R-car, your intersection control delay is dramatically reduced. Okay, that you no longer will have the blockage for the, especially the right turn traffic. They will not have any blockage. They can get to the intersection, turn right. Okay, and we did introduce some geometric delays, but if the traffic volume is high enough, we can show that the time it takes for the driver to come here, do a right turn, a U-turn, even though this is 2,500 feet distance, they come here, the total travel time is very comparable during the peak hour. But during non-peak hour, you do have to travel some extra travel time, okay? And this is another visualization we did. What happened if your traffic demand in all directions increased by 10%, 20%? For two-way stop control, because the minor road capacity is already at its limit, any slight increase in traffic demand, you'll see dramatic increase in the total travel time. Those are all intersection control delays, okay? With our car, because it's way below its capacity potential, even if I have 10%, 20% increase in traffic demand in all directions, the total travel time will be very marginal increase, okay? In all cases, the travel time for the major road traffic was not affected because they still have the right of way, okay? So competing design, you got three options, okay? This is the one that the state DOT would propose to solve the safety problem and also the capacity problem for minor road. And the local citizens in many public meetings, any location they go, this is what they will fight for, okay? And it will give you the mobility and safety, but the average in rural areas is cost more than $10 million per location. With the traffic signal, it penalizes major road traffic and serve the 5% minor road traffic. If the volume is not there, speed is high, it doesn't really improve safety. And cost-wise, this is a cost range. With our car, this is the argument that we made. It preserves the major road capacity while increasing the capacity for minor road, right? And it is very effective in reducing fatal injury crashes, and with a cost that's comparable to signal, but only a small percentage of the grid separation. Okay. Oh, okay. So, this usually this got eliminated. Then the next thing we want to do is why we want to do RCUT. Okay, for state DOT, they only have so much money for safety improvement every year. If we do an interchange, that's going to cost $10, $12 million. They are going to spend all the safety improvement fund on one project, okay? And the other benefit, you have the mobility, but the safety benefit you get will be elimination of 4 to 6, maybe fatal injury crash in this case. That's all it is. You are not going to get more benefit. With RCUT, if I spend the same amount of money, I can improve the entire corridor. I can improve 10 to 15 sites. Each site has the potential to reduce 4 to 6 fatal injury crash. And so what you have is spending the same amount of money for the state, that's going to give you at least 50 reduction of 50 fatal injury crash. And that's a number that's going to help the state to move toward their safety goals. And reduction of 4 to 6 fatal injury crash probably will not help move the numbers, okay? So there need to be understanding between different parties. Yes?
So you're saying the cost for like the bridge, the $1, I'm confusing it.
No, not one, this is the one interchange. The cost of one interchange is equivalent to the cost of 10 to 15 RCUT. Well,
traffic signal interchange or there's grade separation?
Grade separation.
Oh, you're talking about so interchange
Yeah.
grade separation.
Yeah.
Okay.
Okay. So conclusions at the grade intersection. If we are talking about improving safety at grade intersection, okay, we promote some kind of different kind of alternative intersection design, and basically they include rerouting of certain traffic movement. That will result in elimination, relocation of certain traffic conflicts, and it doesn't make everyone happy. It requires sacrifice of small percentage of users. They have to travel some extra distance. They have to bear some sacrifice for the overall benefit of all the users. Okay, and visualization help us illustrate the following. All these different design aspects of the RCUT design. And it illustrates how different users navigate through the intersection, okay? And also the driver thing we put in there help the local citizen understand, there's so many tasks you have to execute when doing the U-turn followed by right turn followed by U-turn. So you need to have enough distance to do that, okay? And these are the material that the state DOT they use to conduct different meetings, and the intersection I've talked about that has been approved for RCUT. It's going to move forward. Construction, I was told, will commence next year. But the intersection that has all those crash videos, that one is too severe. Even though we know it's going to help solve the problem, there's such a strong opposition from the locals. That one eventually they went through not a full grid separation, but partial grid separation. Okay, so it's still going to cost them $8 million. Okay, but the intersection I'm talking about is only about 8 miles from that intersection, and so it does help. Okay, so that's the end of my presentation. Any questions?
Any questions? Please.
Is there any effort on the part of the local agencies to educate the public on the use of how to properly approach and navigate these?
The state they do a lot of this kind of public meetings. This is the material we put in here. The videos, they're on the YouTube now. So this one way we do our part of the outreach so that the people understand how to drive this kind of intersection.
And stuff like that.
Yeah.
Some of the things sounds kind of interesting.
Yeah.
How difficult was it to gain consensus from the community before you had visualization?
Every meeting is a battle, So, so this is not for us. It's not uncommon. I was told every public meeting is a battle, but often when the condition is right, after we implement this, 6 months later, and the local will turn to change their attitude. In some incidents, they even came to the district office who wanted to install an RCUT design at certain locations.
So it converted from a battle to people actually volunteering their locations.
Yeah.
Can I ask what kind of software that was that made the little simulations with the mirror?
Okay. Yeah, the simulation itself was done in Visium, and we output the simulation result into a text file, and then Jason we import those data into his driving simulator. So he actually using driving simulator to create all those videos.